So for our project, we're going to be doing Project Cybertruck by Team Overkill. So for the team members, it's going to be Papa, Andrew, myself, and Jack. Our goal is to create an automated car, a RC car that can navigate through a maze while avoiding collisions. The car will have the ability to stream videos as well as take pictures of potential collisions.
And so for the final prototype that we're going to be having, hopefully it will have a various sensor on both left and right side of the car, and as well as in the front. And the front sensor will be hooked to a server that will be able to rotate the front sensor around and detect whether it should go left or right, depending on the situation. We also will have motors on both the front and the back wheels, so we can move forward and backward.
And then for some practical applications, it can be viewed as a smaller version of an autonomous car. So like a Tesla that can navigate on a road and avoid other cars and obstacles using those sensors. Same with delivery robots. A lot of food services and companies like Amazon are using robots to autonomously navigate to deliver items to customers. And it could also be used as a mobile surveillance system because of that camera and the ability to live stream as well as take pictures. You can keep an eye on things in a remote location.
And for the hardware components, we're going to be using multiple ultrasonic ranging sensors to look at the surroundings and avoid collisions, as well as map out the environment. We're going to use the camera to see what the car sees, both in taking pictures and in streaming. And then we will, for the RC car, it's going to have a front motor for turning, a back motor for going forward and backward, and then we're going to use a controller, a module to control those motors and hook it up to the Pi. And then for the hardware diagram, everything that I previously mentioned here, it's hooked up to the Pi, which is going to talk to the web server, which is going to talk to the website and allow the user to both view and interact with it.
So for the software diagram, we'll have on the Raspberry Pi side, we'll have a distance sensor class, a camera class, servo class, car class, and a database controller class. In the car class, we'll have the functionality of turn motor and movement motor. The Raspberry Pi will have access to the database. On the camera side, we'll have a live stream set to display on the web interface. Here we'll have a snapshot view, video stream, website, and then remote RC control.
And then for the member responsibilities to start off, I'm going to be doing the fritzing diagram, and I will be the host of the RC car and the main Raspberry Pi. I will be doing the hardware hookup for the RC car and the component code that goes with that.
I will be working on the web interface and model or web model, and I will also be mainly focusing my work on the different various camera function and how it will communicate with the database and storage.
I'll be responsible for administrating the Git side of things. So version control, I'll be um, basically in control of that. Make sure people are working in different branches and merging them back that way to the master branch. Also, I'll be building the template code for the project, and then I'll be working on the database controller on the Raspberry Pi side and the RC car component code.
And then I'm going to be working on the web module meant for the user to interact with, as well as integrating and verifying that all the data sent from the Pi, as well as the web server, is correctly displayed to the user. So that is our project proposal for Team Overkill. Thank you for watching.